Transistors revolutionize technology like no other device. Inside your phone lies a processor, and that processor is made up of approximately 2 billion transistors. Around a century ago, computers were huge. Some were so big they can take up a room. The dramatic decrease in the size of a computer was made possible by transistors. Before we dive into how a transistor works, we need to first understand the basis of transistors. Transistors are made up of mostly silicon. Silicon has 4 valent electrons. However, they cannot move because they don't have the energy required to do so. A method called doping is used to improve the conductivity of silicon. There are 2 types of doping, N-type and P-type. In N-type, phosphorus is injected into the silicon, creating a free electron which can move around. In P-type doping, boron is injected to the silicon, creating a hole where electrons can fill. We're now going to take a look at the close relative of a transistor in order to better understand the transistor itself. This is a diode. Notice that half of it is N-type and the other is P-type. Free electrons from the N region will migrate towards the P region in order to fill the holes. However, this will make the P region slightly not positively charged, negatively charged, and the N region positively charged. This makes electron flow impossible in this case. Oh, wrong slide. Excuse me. We can solve this problem by adding a voltage. For example, this is the positive charge and this is the negative charge. Electrons inside the P region would be attracted to the positive terminal and repelled by the negative terminal. But this will only happen if the battery is strong enough to overcome the depletion layer, the change in the charge. Now it's transistor time. Transistors are basically 2 diodes sandwiched back to back, this one and this one. However, that means that whichever way we apply the battery, one of the diodes will be blocked. We can fix this by adding 2 voltages. Let's call them V1 and V2. When the electrons from the N region will migrate to the P region to fill the holes, some of them will get attracted to V2's positive terminal, while the others will go to the collector and be attracted by V1's positive terminal. Now the transistor is in the on state. If V2's electric current isn't strong enough to overcome the depletion layer, then the transistor is off and electron flow is impossible. This transistor is also a good example of current amplification. The small base current, or the V2 current, is amplifying to the very large V1 current. It's flat time. There are around 10 trillion transistors in a modern laptop, and N means negative and P means positive in doping. However, this doesn't mean that in the P region is actually more positive than the N region. When in N-type doping, it's the electrons that move, but in the P-type doping, it's the holes that move. But phosphorus has the same amount of protons as electrons, and so does with boron. Thank you for watching, and see you next time.